Welcome. Welcome to all of you, external guests. I'm going to single out the deans who have come here en masse in support of a fellow dean. And one of them looked at this and said, "Oh, that looks wonderful, wonderful." And I said, "He hasn't started to say anything yet," but they really, obviously, clearly have his back. And welcome to colleagues from other schools, particularly our professoriate from across the university. So if there is, I think for external guests, I am Tara Dean, I am the provost at the university. It is my pleasure to really introduce this inaugural lecture of Chris Harty, who is the Dean of School of Built Environment and Architecture. As I'm sure you all know, the inaugural lecture is a really key milestone in a professor's kind of time where they can share their career, their achievement. For the schools, it's equally important because they can share with the wider school community, students, the achievements of their professors, maybe shared with the alumni, foster new collaboration, and so on. But I'm sure many of you are really here to find out a little bit more about Prof. Harty, because he hasn't been with us for that long. So for the university, obviously, these are seminal events because they capture what we do, our contribution in terms of both teaching and research, and what universities are here really to do. So inaugural lectures are now all recorded, and so you will be able to watch this in a few weeks' time and put it on repeat if you like, if it's any good. And they also, with a kind of in-person meeting, I have to remind you there is no fire alarms or anything like that. So please, if you hear it, exit through the door in a calm fashion and turn off your phones because we are recording the event. So let me tell you a little bit about Professor Harty. He is a professor of technology and organization and was in fact promoted to a professor in his previous institution at the University of Reading back in 2015 and joined our professoriate here in September 2022 when he joined us as Dean of BEA. This will come as a surprise to many. Many of you may not know that Chris's educational background was not in fact in architecture, built environment, civil engineering. His first degree was in combined studies of sociology, history, and English at University of Northumbria. He gained the first class honors and then was awarded the Tempest Prize for overall academic achievement. He then completed his master's in contemporary sociology at Lancaster University and stayed there to complete his PhD under an ESRC case award scheme. He had a brief stint at Loughborough University as a researcher and then eventually secured his first academic position as a lecturer at University of Reading. In fact, I have it on good authority that Prof. Harty only came into academia because he was unable to earn a living playing in a rock band in Cumbria. So music industry's loss was certainly academia's gain. Chris rapidly moved through the academic ranks to a full professor and was then appointed as head of School of Built Environment at Reading in 2017. In fact, when we were recruiting for Dean of BEA here at LSBU, Chris was recommended to me as an external to serve on the appointment panel. So I contacted him, shared the candidate pack with him, and I asked him if he would be interested in serving on the panel. And to my surprise, he said, well, actually, I may be interested in applying for the job. And if that's the case, I can't serve on the panel, and of course, the rest is history. Chris has maintained a sterling academic record throughout his significant leadership roles. He has been returned to Ref 2014, Ref 2021, has supervised and continues to supervise PhD students, has not only mentored early academic researchers, but also newly appointed heads of school, has been editor of journals, expert reviewers for ESRC, EPSRC, has led on externally funded projects, and has had significant STEAM measures, including visiting professorship in Sweden and Denmark, and more recently as chair of board for the Building Services Research and Innovation Association, BISRIA, which is an organization that provides research and knowledge-based consultancy and support services to the building services sector worldwide. Those of you who attend these lectures know that I usually go to colleagues within the university to get a little bit more information, personal information about our professors, and try to weave that in my introduction. I couldn't really do that for Chris because he's only been here a few months, so I then had to go and dig out his cover letter for the position he applied for and have a look at his references and see what they said. In his cover letter, he stated that his vision for BEA would be to transform it into one of the best and most inclusive schools for built environment education, industry impact, and research in the UK. Now, if you are from BEA, I'm sure you agree with me that this is a journey that he has certainly started and has support of all those who work closely with him, including myself. His referees, they were quite senior, the VC, the PVC at Reading, said that he was a very well respected and competent academic leader. He was described as a collegial and measured individual whose sensible, calm nature and firm yet fair approach meant he pulled together positive outcomes when other areas of Reading were in crisis. I won't go into that, you maybe want to share that. His ability to see the larger strategic picture and communicate this to his staff in a way that built consensus and buy-in was also a theme across all his references. In fact, one of his referees suggested that any university would be lucky to have Chris, and we are indeed very pleased that he has chosen LSBU as his academic home. He is a pleasure to work with, and I look forward to working with him, moving the school forward under his leadership. As someone myself who is quite excitable, it's lovely to have Chris on the team. And I have become really appreciate and value his calm and laid back, in appearance anyway, nature. In fact, I wrote to him about a week ago saying, are you okay about the inaugural lectures? Have you got everything you need, all prepared? And his reply to me was, I have something resembling a presentation, and I know where to turn up. With that, I invite Prof. Harty to deliver his inaugural lecture.
Thank you so much, Tara, for those words. I think I need to see if this works. I can be quite loud, so hopefully you can hear me at the back even without the microphone, but it should be coming on. It's still flashing. Anyway, yes, thank you. It all sounds rather nice when it's all tied together like that. It's some of the research stuff feels something like a side hustle these days after having been a kind of head of school for some time before coming here. So yeah, welcome. Lovely to see you all. Faces that I know, some faces that I don't know, which is great. And I want to talk a bit about some of the research that I've been doing over the last probably 10 years or so, the storyline in this particular kind of version. And I won't dwell on the sort of, the kind of retirement speech CV aspect. I think Tara's done a bit of that sort of stuff for me. I think it's worth pointing out, so I am a sociologist. I got into built environment and construction because I was interested in the way collaborative information technology primarily, but other sorts of technologies are used or attempted to use to try to coordinate complex activities, to join firms together. Construction is a really interesting place to look at for that. And what the particular bit of sort of sociology that I locate myself in, which would be generally called something like science and technology studies, is really about paying attention not just to the social, the people, but paying some attention to the material, the technology, the stuff. And because the argument would be that without the material, whether it's the built environment, whether it's tables and chairs, we don't have those social structures. We need raked seating and big screens and a desk for this kind of talk to work. And so it's about analytically thinking about how the material, the digital, is part of those networks of practices that also involve people and process. So I think that's worth sort of saying. Most of the people in here perhaps knows the construction sector. It's worth just saying a few words about the construction sector in the sense of what it's like. It's often described as unique. It's not particularly unique. It has a combination of features which you can find elsewhere, but it's characterized by very long and complicated supply chains, lots of interaction across networks of firms, a lack of a sort of integrator. There's never one powerful actor at the center of construction projects unless you have a kind of client who's very experienced in building, but then they would tend to not be construction firms or design firms. So there's a complex series of who's in control, lots of contractual engagement, lots of contractual problems, often characterized as inefficient, unproductive, needs to change, uninnovative. I'm going to make entirely the opposite argument this evening, but that's the characterization. But stuff gets built. Look at this fantastic building around us. Construction, design, engineering comes together and makes fantastic buildings and also makes much more mundane buildings. So I think it's worth just pointing out construction is often kind of placed in a sort of problematic position around its organisation and its productivity. And for many, many decades, different forms of technology have been seen as the answer, the panacea that's going to fix everything. And I've spent probably 15 years now being quite critical of that political and often industry agenda around improvement through technology alone. The final little bit of context is just for those that don't know about building information modelling. And again, a lot of you will, but there's lots of talk about building information modelling in the construction sector, in the design and construction sector. There has been for 10 or so years now, ever since the government mandated its use on public projects in 2014. Now, all building information modelling is building the construction, the building, virtually in 3 dimensions first, making sure it all fits, the stuff that's coming from the different design engineers, from the architect, and putting it all together as a virtual model, coordinating it, make sure it fits, and then go and build it. That sounds very simple. And as I say, the government mandated its use on public projects. It went with a bit of a whimper in the end, to be fair, but it's a lot of the work that I've done has been around the attempts to use this kind of collaborative 3D modelling technology to drive change in the sector. So, here we go. So the use of digital technologies, debate and activity around digitalisation in various forms, it does actually at this point feel like it's at something of a crossroads compared to, say, 10 or 12 years ago. There's been some real significant changes, I think, in the way technology, and especially these sorts of collaborative IT systems, are employed across design and construction. and there's a big ambition around what technologies should be able to do, what the potential for improvement in construction projects and efficiency. This hasn't gone away, but my sort of provocation is there actually any evidence that we're seeing a substantively different, more integrated, more coordinated, and ultimately effective construction sector? Question mark. So today, over the next sort of 45 minutes or so, I'm going to offer a certainly contestable and very personal, I guess, narrative of the developments of the technology and research agenda around this stuff over the last sort of decade. It's partly a narrative of progress, but also partly a narrative of fragmentation. And we're going to move from early work on digital integration and the beginnings of this idea of BIM as a 3D coordination of the construction process, moving into programs about mass awareness campaigning around the use of technologies, organisational efforts to align practices to emerging standards around the use of these technologies, through exploitation of virtual reality, hardware developments, and rather ambitious attempts at cross-disciplinary and cross-sectoral integration around and through the technology. But I mentioned standards there, and I'm going to start with this, and this frankly sums up the whole of the next 45 minutes. And this could be in any sector, but, well, I'll let you read it. Standards are not standards. One of the first times I went into a big design office, I was doing my PhD, it was some years ago, and there was piles of paper, stacked printouts like this all over the place. And I'm walking around going, what's that? That's a standard. What's that? That's a layering standard. What's that? That's the CAD standard. It's like, they're not standards if you've got so many of them. But I think this is often, the idea is we can solve it with a standard. We can solve it with a technology that will drive the organisational processes or drive the professional processes. And I think that's quite neat, the way that sort of sums it up. But let's move on to some research. So this first project I want to talk about, it was before the government mandate around BIM. So before there was this real evangelism about BIM as the saviour of the sector, but there were some sort of early movers, some kind of innovative firms that were exploring the use of this 3D technology. This particular project, it was about trying to be more efficient, more effective. It was a huge hospital project, not far away, Barts in London. It was £1 billion PFI project that was happening in the early 2010s. And this is a sort of story of, I guess, actually for such a large project, rather informally organised innovation. So I talked about the use of bringing together these 3D models, coordinating them, making sure everything works. And there was a group of people across the architect, consultant engineer and contractor that had worked together a lot. And they wanted to see if they could explore some of these technologies and explore some of the benefits that they could get from them. Now, for some people familiar with BIM, this will now look rather mundane, but it wasn't at the time. So by putting together all the design information and the project kind of timescale, the scheduling, you can do things like briefing of what's happening over the next period. You can do snagging of where progress is happening on the construction project overall. You can do this clash prevention, which is looking at where, if you'd have gone ahead and fabricated the pipework and the ductwork and the structural steel as per those engineers' drawings, it wouldn't have fit when you got it on site. So we do the clash prevention first, we redesign, and then it all fits together when we get there. You can do health and safety reviews. You can find those points at which there is a problem that would cause a health and safety issue. That's a plant room with a beam over the top of a ladder. And you can also do things like material takeoff. Can the model please tell me how many doors of a certain type I need to buy for this hospital? So they're doing all this kind of neat stuff around the design. What was actually quite advanced at the time was starting to try and take this onto the building site. And this is the days of, like those huge laptops that had all the padding on, real sort of chunky sort of stuff. And they started to look at doing things like construction planning on site. This plant and equipment installation is quite interesting. That box you can see is the box that an MRI scanner comes in, or would have come in about 2014 or 2015. They're doing this design about 7 years before the hospital opens and the scanner turns up. So somebody had the idea that, well, will it actually fit through the door? Right, and they took the box, they mocked up the box, and they pushed it virtually through the model. And just to get this one particular scanner into the right place in the Barts Hospital, they found 80 points at which it wouldn't fit. And so they were able to change the schedule to make sure they weren't doing some of that work, and in fact did some redesign to make sure they could actually get the scanners in. So things like that, drawing retrieval on site, having a laptop with all of the construction drawings there on site with you, rather than rolled up paper plans in your back pocket. Room progress monitor is interesting. You have to sign off every room as complete. Are the sockets in the right place? Are the light switches there? Is the finish on the floor? Are the ceiling tiles in place? This was always normally done on bits of paper, tick it off, tick it off. This was all being done inside the database that was running the model. And again, what was also interesting, they were starting to take this technology onto building sites. Now that happens more routinely now, but it's still not particularly prevalent. And indeed, by Reading Station, where I come in to the office, there's a big 15-storey high-rise going up. I was looking today, it's very high-tech, it looks great what they're doing. You can't see technology, you can see sort of gas cylinders, and you can see lots of high-vis, and you can hear lots of banging, but you don't see much technology. So this was still quite unique, quite novel. So, I mean, what's interesting about this is the first thing is this wasn't the mandate, this wasn't enforced, this was about some people within these organisations thinking, actually, we could probably do something quite useful with this 3D technology. We've heard about it, we'll pick it up, we'll have a go. So there you go, we decided to use the 3D model. But it also comes with almost like the first warning. You can't do BIM half-heartedly. You do it or you don't. You can't say, I'm going to do that bit in BIM and I'm going to do that bit in 2D and on bits of paper and back of cigarette packets and all the rest of it. Now, if you just think how significant that is, a £1 billion PFI project, you have to do the whole thing for it to work. Now, that's a contestable argument, but still, this is what they were saying. So it's a big shift, a big reliance on the technology. And then also, which we'll come back to a bit later, you start to see the age-old divide between the architects and the contractors. Yeah. So the contractors are saying, it's taught us we have to be really careful in the designers we select, i.e. get the ones that can use the technology, will provide the information, will do things properly, And the architect's saying, actually, we've got to encourage the direction of where this is going. The designer, the architect has to be first, has to be at the centre of this process. So the technology is new, it's experimental, and yet it's reproducing the same kinds of tensions between who is in charge of the process that we've been seeing in construction forever. And I mentioned at the beginning this idea of not being one person, one organisation, one integrator in charge of how things happen. So what we've got is a huge project, but some relatively informal, relatively small kind of attempts to try and find some efficiencies from this new technology. It was actually quite influential, this project, on what then became the BIM standard, which has now gone beyond PAS and BS 1192 to ISO 1650 or whatever it's called. They keep shifting. There were some interesting things to make this technology work. £1 billion project, I keep saying that, but it's huge scale. The database that made all of those on-site things work was one guy in his spare room with about 25K's worth of consultancy money. So this whole project, this whole innovation, this whole significant kind of new way of working was hanging off one chap doing some coding in his back bedroom. And again, this is shows some of the oddities of construction in terms of how big stuff can hang off really tiny stuff. And I think the truth is there was lots of parallel passes. So the laptops were being used on site, but that was only actually a small portion of the project work that was going on. This was almost like a set of informal innovation within a bigger project. So it was innovative, it was new, they were developing new ways of doing things, but this wasn't fundamentally impacting significantly the delivery of the project overall. It's kind of small scale. Okay, next one. We're going to switch and to looking at people's willingness to use technology. And so sometime after we were, or maybe at the same time we were doing this case study, we ran this survey, and we used something called technology awareness model. And it's about people's willingness to use something. Frankly, it's conceptually a bit dodgy, I think, but it's used in lots and lots of different ways by lots and lots of different researchers. So it has a kind of validity in the thousands of times that it's been repeated with relatively standardized questions, which is the way lots of the sort of psychological sort of testing works. So we managed to get a very large contractor in the UK to send this survey to every single employee in the company, in the UK part of the company. I think about 6,000, maybe something like that in total. And it had a sort of set of responses which took out the people that were working in the canteen and all that sort of stuff to get to those people that were actually delivering stuff on projects. We got 1,200 responses. It was the biggest survey of this type at the time. I think it may well still be the biggest single company survey of this sort of type. And we asked questions about BIM. Had they heard about this building information technology kind of stuff, this modelling technology? What did they think of it effectively? So it was kind of interesting. I mean, the company had done this sort of mass campaign, this mass awareness campaign, saying BIM's coming, BIM's the thing we want to use, BIM's going to make us efficient and effective, BIM is the future. So we say, have you heard of BIM? You know, and well over 80% of people are saying, yes, we've heard of it, and only a small number haven't. But have you used, or are you using BIM? Much smaller number. So people are aware of it, but it's not really happening in the organisation. So here's the sort of willingness part, you know. Can you read that okay? If the choice was up to me, I would. The top one there is use BIM. Definitely. Nearly 50% said they wanted to use BIM. Probably, again, a large figure. Not sure and no thanks. Very tiny numbers. You know, if I was working on a project that used BIM, I would use it. You know, the big bar is as much as I could, you know, as necessary. So a kind of willingness about future use here around the technology, but not much use. And it was a complete coincidence that 84% of people would definitely or probably want to use building information modelling if they could, but 84% of those people were not using it. So there's a gap between willingness and wanting to do it and having the opportunity, if you like, to use it and actually using it. And I think this is kind of curious because lots of the sort of technology discussions assume that people learn about the technology, people feel positive about the technology, so people use the technology, right? That's how it works. That's that sort of technology model. That's how it should work. But this wasn't happening. Opinions and behavioural intentions were high. Actual use was low. And I'm not going to go too much into it, but if you then dig around and say, well, okay, what else is there? And we did a series of sort of focus groups and workshops with people around the company, and they just didn't know. They knew there's no explanation. Well, people want to use it, so why aren't they using it? It's technology, it works. Why aren't people just picking it up? And it's because there's something else there, all right? And I still don't have really a compelling answer about what that is. But when you look at lots of technology adoption projects, they don't work. They fail. The system doesn't get used. I'm sure we can think of examples across the university and across previous places we've worked where big investment in technology looks fantastic, doesn't work, nobody uses it. For all sorts of different reasons, but the point is there's something around making big collaborative technology projects happen that is not about implementing some software, training, and making people feel good about wanting to use it. So there you go, willingness and intention does not mean use. That's what this tells us. The company had a clear mission, organisational support from the leadership, investment in innovation, all sorts. But buying the technology and getting people interested and enthusiastic about it was just not enough. And this is where I introduced this sort of idea about innovation, but also scale and scaling up. There's an issue here with scaling up. There's not an issue with trying out the technology, showing it can do fantastic stuff, making it work across a small group of enthusiastic people, but actually trying to get it scaled is difficult. I don't think this is unique to construction. It's just construction sort of inter-organisational dynamics makes it kind of exposes some of those tensions more than perhaps something that sits within one organisation alone. There's a conveniently placed chair that I'm going to throw my jacket onto there. Look, who'd have thought that they would have done that for me? Isn't that good? Project number 3, okay, which is actually a couple of projects. So we're shifting onto, from that sort of modelling BIM stuff onto what else you can do with things like virtual and augmented reality technologies. So this first thing I'm going to talk about here is it was a case study of an ongoing project for designing a new hospital in the UK. It was the competitive tender bid, final 2. There's lots of legal sort of things around that with not sharing information and so on in terms of between the competitors and between the clients, the hospital trust and the 2 tendering teams. At the University of Reading where I was, there was a cave. It's a very old-fashioned technology now, but it's an immersive virtual environment using multiple projectors to create a small space that you stand in with the sort of goggles on and everything looks 3D. It's like what we have now with HTC Vive, Oculus Rift, PlayStation VR, but now it's a little headset. This was an actual space that you stood in. And one of the sort of bidding joint ventures came to me and asked about using the cave to demonstrate to the trust how the design was operating in terms of it being single room accommodation. So single room accommodation for the whole hospital, there are visibility issues with that compared to ward design. So they wanted to know, what does the single room look like, and can we sort of see, is the visibility enough, where do the nurses have to be? So they wanted to see if rather than what they would have done traditionally, and indeed what the other tendering consortium did, was build a one-to-one mock-up of part of the ward, part of the single rooms in the nurses station. Quite expensive. Do it in VR with the sort of with the 3D model. And what we did is we had these design meetings to try to sort out what they were doing with presenting this to the trust, and we basically were in there videoing and audio recording. You're doing a sort of video ethnography around how those designers and sort of construction professionals were going in, interacting with that technology, using that technology, and how they were reacting to seeing it in this virtual kind of space. Which was kind of quite interesting, as I'm sure you can imagine. So the first thing happens is it's all a bit of a shock. So there's a thing about kind of trying to orient yourself to being in this weird environment. So it feels like it's bigger than it is. And people were always walking into the sort of the walls because it felt like it went further than the actual physical space itself. And they're sort of getting ready to it. Then you sort of start to see this honing in on detail, which is detail you wouldn't get even with a 3D model on a flat screen like this. So things like, is that handrail actually at the right height? Because you can't feel it, but it's right in front of you. Looking, is the toilet at the right height? Is that too high? Is that too low? And really sort of starting to pull out details that you wouldn't do even with the 3D model on a flat screen. But then the really interesting thing happened, which they start to shift from being designers and start to imagine themselves as the users. What will a nurse think? Can the nurse see? Can they look into the room? How easy is that to sort of move trolleys around where we've put the bed? We did an operating theatre as well, and how much access room is there? Imagining themselves as patients. If I'm a bariatric patient, do I feel like I could actually be in this bathroom in the single ward? And so this shift to this technology this immersion allowing them to sort of start to think about other roles, think about users and clients and what they might think about the design, which is interesting. I mean, designers do that anyway, but it felt like it was doing something which was somewhat different to just talking about the opinion that somebody might have, to actually trying to experience the space as a nurse or as a patient in this case. And then, heaven forbid, you can also get the users involved. So this was a sort of related project, which actually was a hospital in Sweden. It was the same main international contractor. And it used slightly different technology. It had the screens and one of these sort of interactive tables where you could move stuff around. And this was about hosting a bunch of collaborative sort of design workshops using this sort of technology system at Chalmers University of Technology, where I was a visiting professor for a number of years. Again, we were videoing and recording what was happening to look at the interactions between the architects and the nurses that were in these design workshops. So we were looking at the layout of operating theatres. And you can see some of the images there. And you could sort of move the stuff about. So it's quite up there. You could sort of use the table to sort of shift things around on the plan, and it should then update the 3D model behind you so you can see what it looks like when you move stuff around in plan. And that was quite interesting because, well, it says there that the users, because this is quite intuitive technology, you know, I can shift the bed, I can shift this bit of kit, and it'll update, and I can then look at how the room would look or how the theatre would look. The nurses just sort of pushed the architects out of the way, took the tools off them, and started using it and talking to themselves. You know, oh, you can't do it like that. You know, they just jumped straight in instead of allowing the architects to sort of facilitate a discussion about, oh, does this look right? Is this the right configuration? Is this the right layout? And you can see them grabbing the sort of pen so they can use the sort of table. You know, the architect walking off in disgust because they've been cut out of the conversation, and them just getting on with it. And again, I mean, this sort of idea of challenging, if you like. Well, you could call it a democratization of this sort of expertise, I suppose, if you want it to be grand. But you can certainly say it's challenging those sort of distinctions between expert and lay. You know, the architect is the expert in this case, but this technology actually allows the nurses, who have a different sort of expertise, but not design expertise, are able to actually go in and do stuff. And so it's a kind of almost a challenge to the sort of disciplinary status. And I kind of talked earlier on about this sort of age-old tension between the architect's design and the contractor in terms of who's in charge. And here you get users coming in and almost imposing their own, how dare they, kind of sense of what they think as the users, as the experts in the use of this sort of infrastructure of these buildings. So the tech kind of leads to these sort of new uses, but also challenge those expected ways of working. Okay, there was always going to be robots, and so now we're on to the robots. So the fourth project I'm going to talk about, and it's the last project I'm going to talk about today, was around trying to use sort of small-scale robotics to, let me just find my right page here, there it is, to automate particular processes, small-scale automation of processes that would normally happen on a construction site. So this was effectively Innovate UK money. This was about 1.5 million from, well, 750,000 from Innovate, and then 750 from the companies, from the consortium, to develop this idea of a sort of almost like a flying factory, something which, you know, kind of as these robot arms were getting kind of smaller scale, more effective, cheaper, to see if we could make a sort of small scale automated process. The conversation about automation in construction goes back decades, and, you know, go back to the sort of 70s, and people are talking about bricklaying robots that don't work. And frankly still don't work, but there you go. It's an old age thing, automation in construction, trying to make it more like manufacture, trying to make it more in a controlled environment. So anyway, I was lead academic on this project around these flexible robotic modules for assembly and built environment kind of applications. So we had a robotics manufacturer, and we had the sort of building services bit of a big engineering contractor, and various other people. We had a sort of lean construction, a sort of process improvement consultant, and so the story of the project would be it didn't work very well. It was quite hard to make this stuff work. It was quite hard to think about how to take bits of an on-site process out of the construction site into a factory, make that process happen, but then insert it back in. So that's the sort of highlight, I guess. But what was actually quite interesting about it was the kind of inability of the two sets of professional, well, let's say the two sets, the construction side and the robotics side, to frankly have a clue what the other was talking about. They just were unable to really get to grips with understanding what either of the side's needs were in terms of what the construction automated process should look like, but also what the robotic technology can actually do and how you make it do it. So we looked at this through this sort of idea of, some might have heard of this idea of sort of boundary objects. So the idea of boundary object, it's a thing that kind of means something to two different sort of groups, maybe two different professions, two different sort of epistemological groups, and this thing can pass between them and carries some form of meaning back and forward. So it could be kind of, standardized processes, it could be a piece of technology, but there's quite a lot of research around the use of these sorts of boundary objects. Again, it's a bit of a contestable term. But I guess the point of this project is they tried through things like flow diagrams of process, through trials using particular types of kind of coding, particular ways of coding what the robot arm could do. They tried to speak to the factory workers that would be doing, in this case, the kind of welding and cutting. But even they couldn't really put their tacit skill with a welder into a kind of format that the robotics engineer or the software programmer could really kind of understand and pick it up. And so we sort of kind of saw that as this sort of, these different epistemological perspectives, this sort of struggle for epistemological difference. The robot guys were saying, well, just tell us what you want. And the kind of construction guys, the factory guys were saying, well, just tell us what it can do. And they couldn't quite get in the middle. Here's some more pictures of robots trying to cut and weld things. So they were trying to sort of use various types of visualization, but also various sort of test prototypes to try to get this mutual understanding, and they couldn't. They couldn't kind of make it work. And again, so I would say, the sort of professional, the epistemological, the knowledge differences were really hard to reconcile in this relatively quick, and it was quite a lot of money, but relatively quick and relatively small scale demonstrator project. Didn't have the time to build up that kind of joint understanding, that joint sense of how this could work as an automated process. So, these epistemological and professional differences are very hard to reconcile and negotiate. So, we're going from me saying construction is very complex with all sorts of different designers, engineers, contractors, parts of the supply chain, to then also get robot people involved or to get computer programmers and software companies involved. It makes it even harder to try to get these sorts of practices up and running, to develop these new ways of working. Real uncertainty around knowledge and intentions. So a summary then of 4 little sort of vignettes of those cases. So, we've talked about informal, quite extensive, but sort of project-based innovation, the first case of people sort of getting together and trying to make things happen. But it also reveals where some of those problems are, some of those problems of scaling up, some of those problems of getting things across organisational boundaries and into a significant amount of use. There's more to technology application than access to it and willingness to use. If there's one point to take away, it's a point I've banged on about for quite a number of years. You know, technology does not solve the problem. Implementing some technology will not make things change, will not fix a problem. And indeed, you know, often when you implement these systems, they break down at the points at which there is already some sort of tension or barrier or boundary. We can see lots and lots of really fascinating uses of this information technology. You know, the use of this information management approaches leads to lots of possibilities. And there's lots of things going on in my school which are exploring these sorts of possibilities. So it's positive, but it's not making substantive change. I think that's the argument I'm making. VR and AR, virtual and augmented reality, well, they're really interested in the way they may be starting to challenge professional boundaries, professional competencies, and the distinctiveness of those. You could probably, or I could probably, if I sat down and thought about it for long enough, you know, put things like AI, ChatGPT in there in terms of how their technology that's starting to break down distinctiveness of sort of knowledge, because they can, you know, assimilate and emulate from that wide variety of sources. But, you know, challenges to professional competence, challenges to the divisions of labour, expert, lay, you know, kind of professional user. And where there are integration possibilities, where there are attempts to do this, there's a lot of hard knowledge work that needs done, and it's not easy, it's not straightforward. And so it's not much of a surprise then that we remain in these sorts of professional and disciplinary silos in the construction sector with differences across different, but because it's hard to bring that together, it's hard to make new knowledge integrating and transforming those different sets of understandings. So the challenges are significant. You know, trying to develop this technology, trying to develop the practices around it, they reveal some of these real significant challenges of using it to bring about significant change. You know, they imply we need to do an awful lot with the way design and construction is currently organised, and it looks very similar to how it was 30 or 40 years ago. And that key thing about having no core or integrating actor in the middle. If you think about stories of what was happening in automotive manufacture in the States in the late 80s, they were getting beaten senseless by Japan, and they had to change the way they made cars. But there was always a Ford at the centre who could beat up the supply chain to go through that business process re-engineering to then make more efficient cars in the way that the Japanese manufacturers were. Construction design doesn't have that. Doesn't have that kind of actor in the middle. And again, you get the odd, what we would call educated client who can try and push through by saying, well, I'll only hire those companies that will work in a new way. BAA, as was, used to be like that before they were taken over some years ago. But it's very difficult to make that happen. It's difficult to make it happen anyway, but even more when no one's in control. So more than organisation alone, there are implications around crossing those professional boundaries and you know, what happens when users come and complicate things even more and add more into that mix. These sorts of innovations, these sorts of technology uses are on their own very effective. They can show lots of, you know, they can show, you know, real pounds and pence kind of improvements. But they're quite local, they remain quite local. You know, BIM implies standardization and consistency across the whole thing. And indeed, really the goal around BIM is we use the same set of data, the same model and database to actually look after the building when it's finished. So that I can take my phone and I can point it at the ceiling and it's going to tell me that, okay, there's the sprinkler system, there's the electric cables, I know that light bulb part number is whatever, because that is not happening at all, just it isn't happening. But that was the holy grail. So just not happening. I guess then the question comes, okay, so does it matter? We're sitting in a fantastic new refurbished building here that's won awards. You know, how broken is construction? So, you know, how do we make that decision, or how do we start a debate which is around managing the ability to be innovative and try these new technologies and do these new things with this idea that we're not delivering the economies of scale, we're not delivering the efficiencies, we're not delivering the productivity as a sector. That's what policy would suggest. And so my provocation, where I started, was often construction is characterised as uninnovative. I take it the other way. I think construction is too innovative. It does too much small scale, innovative, rapid, clever, right, really exciting things, but nothing sticks, nothing scales up, nothing significantly changes the way the sector operates and engages with each other. And hence, you know, I think that means we should be rethinking our discussions of innovation. Now, not many people agree with me, but there you go. I think this idea that it's easier to do quick turnaround, small scale, with enthusiastic people, small groups, when you try to make big change happen, you know, and we can see it played in the sustainability agenda, for instance. There's been some of my new professorial colleagues talking about sustainability over previous months. And it's always, we need to make bigger changes, much more significant, bigger scale changes, and we don't see them. And that's because it's really hard. It's easy to build an eco-house. It's really difficult to make the whole sector do nothing but build cheap but zero carbon homes. We're not there yet. Only a couple more slides. I mean, inevitably, I won't dwell on this, but you know, this is the, you know, lots of colleagues have worked with me over the years on some of these projects. Some of them have been quite big projects, and there's some of their names. I'll own the argument, whether you kind of agree with it or not, but that one is my own. And just because we like pictures, so Tara mentioned I'm currently a visiting professor at the University of Stuttgart, and they've got this fantastic €50 million government funding to do all this really fun stuff with pushing construction technology. I was there a few weeks ago. Right, that is a standard size huge crane. It's remote controlled. I was remote controlling it from the ground, and they do this game where one of the problems with cranes is the jib swings, and you've got to be quite skilled to sort of get the swing back under control. It's a bit like when you balance a stick or something in your hand and you sort of move it around to try and keep it upright. Yeah, I mean, absolutely amazing what they were doing. This top one is the supposed thing that goes on the jib that can automatically pick stuff up, and then the bottom picture is a set of two robots that they've developed a way of building using wooden cassettes, and one robot arm picks up the cassette, and then the other robot arm comes in the other side and sort of screws it in, and then it moves along. Absolutely amazing. It was just a fantastic day spending in the labs. It is so far away from ever having an impact on any construction site ever. I mean, it's brilliant, but it's just nowhere near. And I think that's what we do as a sector, and it's actually what we do as researchers, is we push this sort of stuff, and we don't think enough about actually what we can do, what we can use, and what will actually make an impact on the sector. Anyway, I think that's it. Thank you very much.